Let's write the balanced net ionic equation for NaOH plus BaNO3 too, sodium hydroxide and barium nitrate. The first thing that we need to do with these net ionic equations, we have to balance the molecular equation. This is the molecular equation. So I can see right away that I have one hydroxide here and two hydroxide ions here. I'm going to put a 2 in front of the sodium hydroxide. So that balances the hydroxides. Now I have two sodiums here. Let's put a 2 here in front of the sodium nitrate, balances the sodiums, two nitrates here, and we have two nitrates here, barium and barium. So that's the balanced molecular equation. Now we have to balance the net ionic equation. So to do that, we'll write the state for each substance, and that's going to look like this. Compounds with sodium are very soluble, so that's soluble. Compounds with the nitrate ion, very soluble as well. So those three substances are soluble. In general, hydroxides are insoluble with a few exceptions. Group 1 elements like sodium hydroxide or potassium hydroxide. And barium hydroxide is an exception. It's considered a strong base, so we say it's soluble and we write aqueous. So in this net ionic equation, everything's soluble. So everything will be a split in its ions. What we start out with in terms of ions, we'll end up with the same ions. Everything stays dissolved. If we split the strong electrolytes into their ions for the complete ionic equation, it might be a little bit clearer. So on the top are the reactants, the bottom are the products. They're the same on both sides. In the reactants, I have two sodium ions, and in the products, spectator ions, we cross those out. Two hydroxide ions in the reactants and in the products. Barium ion, and two nitrates. And everything's spectator ions, we've crossed everything out. All of these ions up here that we start with, they're exactly the same down here, just a different order. So nothing has changed and there's no reaction. Sometimes you'll hear that this barium hydroxide should be a solid. But because it's a strong base, we consider it to be soluble. When we write net ionic equations, that's why we have the aqueous here. This is Dr. B with the balanced net ionic equation for NaOH plus BaNO3 2, sodium hydroxide plus barium nitrate. Thanks for watching.